Alright, so today we're going to be talking about how to write equations of linear lines. So to write the equation of a line, you're always going to need a point and the slope. One way to write the equation is to plug the point and slope into y equals mx plus b, solve for your b value so you can write your y equals equation. So let's do that. So given the point and slope, write the equation of the line. Point is 2, 1, slope is 3. So this represents my x, my y, and here's my m. So we're going to plug this all into y equals mx plus b and solve for the unknown variable b. So y equals m times x plus b. So 1 equals 6 plus b. When I subtract 6 from both sides, we get a negative 5 for b, which means the equation of my line, y equals 3x minus 5. Very straightforward, very easy. This works out really nicely when obviously they're all whole numbers and the x and the value and the slope goes in each other very nicely. So my next point, negative 2, 5, m is 4. So it's going to be y equals m times x plus b. 5 equals a negative 8 plus b. So I have to add 8 to both sides. 13 equals b. Therefore my equation is y equals mx plus b. Very important to make sure you actually write the equation. Don't just stop with your b value. I need the actual equation of the line. Now, if your slope is 0, there is no need to do any of this stuff to plug into the equation. If you remember, slope of 0 is your horizontal lines. They're just y equals whatever the quarter point is. Simple as that. You would have actually found that, though, if you plug in directly. So y equals m times x plus b. 3 equals 0 plus b. So which is 3 equals b. So y equals 0x plus 3, which is still just y equals 3. A lot more work, though. So if your slope is 0, your equation is just y equals that number, 3. If your slope is undefined, there's no algebraic way to plug in an undefined slope into equation to solve for a b value. In fact, a b value doesn't exist. If it's undefined slope, that's when you have a vertical line. We'll never cross the y-axis if the line is vertical. And if it's a vertical line, the equation is x equals, well, what's the only x value? 6. And that's it. So if you're looking to write equations of lines that are undefined slopes, your equation is just x equals that number. That's it. Nothing else to do it. So if slope is 0 undefined, life's pretty easy. If it's an actual number, then you need to plug into your y equals mx plus b and solve for your b value. Now, I don't have to give you the slope. I can instead give you the 2 points and ask you to write the equation of your line based off that. So you need to do one extra step. You need to find slope. We talked about how to find slope in a previous section. So all you need to do is take those 2 points, plug them into your slope equation to find the m value, and then once you have that, do as we did before. So I'll work this one out with you, and then you'll do a couple on your own. So our slope is need to be found. So we're going to do 1 minus 4, y minus y, over x minus x, 3 minus 2. Negative 3 over 1, so our slope is negative 3. Now, to write the equation, it doesn't matter which point you pick. I'll show it using both points. You'll get the exact same equation. So your y value equals m times x plus b. So 1 equals negative 9 plus b. We add 9. b is 10. Had I done with the other quarter points? Y equals m times x plus b. 4 equals negative 6 plus b. We add 6. We still get the b value to equal 10. So you pick whichever answer you like best to work with. So your equation is y equals negative 3x plus 10. So that's what you're going to be doing on your own for the next couple examples. You're going to find your slope first, using what we talked about last time, the different tricks as well, if the quarter points happen to be the same, and then use that to write your equation of your line. And again, use the little tricks we talked about if they happen to be slopes of 0 or undefined. So I want you to do this one on your own. So pause the video while you work that out, and then I will show you my answer. Okay, you should find that your slope is 0, because your y coordinates are both the same, meaning your equation is just y equals 6. Simple as that. Do the same thing for this one. You want to find your slope first, and then write your equation of your line based off that. Alright, so for this one, we found our slope to be a negative 1/3. When you plug that back in either with this point or with this one, doesn't matter, your equation is y equals negative 1/3 of x plus 6. Okay, and one more. So you want to write the equation of this line based off the given points, so find your slope first, and then go ahead and write your equation. Now for this one, you should have recognized that your x values are both the same exact number, meaning your slope is undefined. If your slope is undefined, you then need to remember that your equation would be x equals the x-coordinate point, negative 1. So that's how we write the equations of a line. If I'm either given slope and a point, we just plug in immediately. If I'm only given 2 points, we must find slope first to then plug in. And then don't forget your different tricks when slope is 0 or when slope is undefined, how to find those slopes easily, and then how to write your equations easily. Now, also in this chapter, we're going to be talking about writing equations of lines based off data tables. Now, we're going to do a very basic example here. So we have this table that shows the number of domestic flights in the U.S. from 2004 to 2008. We want to write an equation that models this data and then predict the number of flights in 2020. Now, there are more powerful ways to model this data and more accurate ways. For right now, though, we're just going to assume it's a perfect linear relationship. Now, we know that's not true because we're going up and then down, then back up and then down. But for right now, we're going to assume it's a perfect linear, meaning we're going to go from here to here is all a straight line. So what I'm going to do is I'm going to assign an x value. We're going to say this is my starting point. So I'm going to say that my x value here is 0, 1, 2, 3, 4. So my quarter point would be 0, 9.97, and my last one, 4, 9.37. If you use the actual years, you're going to get the exact same final answer for your prediction. Your slope will still be the same also. You'll just have a different b value for your equation. So it doesn't matter. I also could have used 2000 as my starting point, so this would be 4, 5, 6, 7, 8. Doesn't matter. So let's find my slope. So slope would be 9.97 minus 9.37 over 0 minus 4. This is a 0.6 over negative 4, which is negative 0.15. And we're going to use this slope now with the easiest point to use is the 0 one. That's why I like picking 0 as my starting point. Because if this is 0, this is my y-intercept value. So my equation would be y equals negative 0.15 x plus 9.97. That's my equation. If you had picked the 4.9, the 4 is your equation, your point to use to write the equation, you're still going to get this answer for your b value. So if you need to pause the video to verify that, go for it. Now, to predict the number of flights in 2020, I need to plug in an x value. Now, I need to be careful about what my x value picked. If 2004 is my starting point, I need to go to 2020 and plug in the appropriate value for x. It's not going to be 2020. It's not going to be 20 either. It's how many years after 2004 I went, which is 16. So I'm going to plug in a 16 for x. And when I do that and multiply by negative 1.5, add the 9.97 to it, we're going to find that our answer is going to be y equals 7.57. I mean, there were 7.57 million domestic flights in the U.S. in 2020 is our prediction. Okay, and again, this equation right here would be different if you pick different starting values for x. You use the actual years for your x-coordinates, you start at 2000, whatever. But this answer had better be the same no matter what you picked. If it's not, then you made some sort of mistake. Alright, one more. So in addition to his weekly salary, Ethan is paid $16 per delivery. Last week he made 5 deliveries, and his total pay was $215. Write a linear equation to find Ethan's weekly pay, then predict how much he'll make if he makes 9 deliveries. So this one's going to be a little more interesting. We need to identify my slope from this word problem, and then I need to identify my quarter point. Well, this right here is what I'm changing by. I'm changing $16 per delivery. So that's my slope. Now, he made 5 deliveries, pay was $215. Well, there's my coordinate point. 5, comma, $215. The reason why the 5 is my x-coordinates is because that's what we're changing. We're changing $16 per delivery. So I have to do 16 times x, or 16 times the number of deliveries there. That's why, since slope is 16, that has to be my x value when I plug into the equation. So I need to use all this to write the equation of my line. So my y equals m times my x plus b. So 215 equals 80 plus b. When I subtract 80 from both sides, I get 135 equals b. So my equation is 16x plus 135. This is implying that his weekly salary is $135, and he gets paid extra based off how many deliveries he's going to make. Well, I want to know how much he makes if he makes 9 deliveries. So y equals 16 times 9 plus 135. And when I multiply that by 9 and add it to the 135, we're going to get 279 for our final answer. Very straightforward, very easy. So the key, again, the hard part really is identifying where your slope is, and that is generally wherever you see some number per blank, whatever we're talking about. That's your slope. And then your x and y coordinates depend upon per what? Per delivery. Your deliveries are your x's. That's why 5 is x. The other number, 215, represents how much he made based off those 5 deliveries. That's why it's y. Alright, so next time we're going to talk about how to write the equation of a line in a different form, point-slope form. So that'll be next time.